All right, hello. So I'm going to try and record a video here explaining how we go from vertex form to standard form. This is a skill that we have been doing in class, and I want to give you guys an additional resource to prepare for it for your exam on Friday. This is my first time recording a video using this setup, and I'm also recovering from a cold, so I hope that the video quality isn't too bad, but either way, you can let me know. So to get started, we have our two ways of writing quadratics. We have vertex form, which looks like this, where we have A, H, and K, and we have standard form with A, B, and C. You see, this one has parentheses, this one does not. We've worked with both of them, and now we're learning how to go from something that looks like this, right, something in vertex form, to something that looks like this in standard form. Because any quadratic can be expressed in both ways. So these two equations here, although they look different, if you graph them, they would be the same equation. So the simplest example of this, and starting with our vertex form that looks like this, the simplest example of this occurs when A is equal to 1 and K is equal to 0, and then H is something different. So here, let's say that H was equal to right? I apologize. H was equal to 2. Yep. Getting used to the setup. H was equal to 2. So if H was equal to 2, when we plugged in all of our variables, right, A equal to 1, K equal to 0, and H equal to 2, we would have Y is equal to 1 times X minus 2 squared plus 0. And this simplifies quite a bit because we know that 1 times anything is just itself, right? So X minus 2 squared times 1 is just X minus 2 squared. And then again, if we add 0, we're not changing the value of anything. So X plus 2 squared plus 0 is just X minus 2 squared. So the simplest version of a vertex form to convert it to standard form is when A is 1 and K is 0. We'll talk about when A and K are different values later on. But let's start with this one. Y equals X minus 2 squared. To simplify something like this, we have to do something called double distributing. And this is a skill that some of you have learned in Algebra 1 and some of you may not have seen before. Either way, I'll go through it here, but definitely come talk to me if you still have lingering questions. The first thing that we notice is because this is squared, right? Anything squared is being multiplied by itself, right? If you have 3 squared, that's 3 times 3. It's the same thing with expressions. If we have x minus 2 squared, we can rewrite that as x minus 2 times x minus 2. Now we need to do our first distribution, I guess. And in order to do that, we're going to need to multiply each part of this first expression, right, the x and the minus 2, by the entire second expression. We're kind of going to distribute this x to this whole expression, and we're going to distribute the negative 2 to this whole expression. Right? If you're struggling to see what I mean there, let me see if I can highlight it. So we essentially have this second x minus 2, and we're distributing this x here to that x minus 2. So the x minus 2 stays the same. Now it's just multiplied by an x on the outside. And we need to do, oh, I apologize. this is wrong. This should be a -2 because now what we are doing is we have to take the -2 and multiply it by this whole expression again. So we're taking each of these terms in our first expression, and we're multiplying them by the entire second expression, right? So we have x-2 and x-2 being multiplied one at a time by each of these terms. You can think about it like, imagine if this expression were two people in a car going to a party, and this expression was also two people in a car going to the same party. At the party, everyone needs to say hi to everyone else at the party who they didn't drive with, right? This x doesn't need to say hi to this -2 because they drove there together, but it does need to say hi to this x and this -2. That's why we need to multiply it by both of them, by the whole thing. And this -2 doesn't need to say hi to this x because they drove together in the same car, but it does need to say hi to this x and this -2 because they came in a second car. So our first distribution here is taking this first expression, breaking it up into the two components, and multiplying each of them by the entire second expression. Now that we've done that, the reason why it's called double distributing is because we've distributed once, now we need to distribute again. So to do that, we take the term out in front and we distribute it into the parentheses. So here you would have y equals x times x, well that's x squared, x times -2, that's -2x. And then we move on to the second part, -2 times x, that would be -2x. Then we have -2 times -2, that gives us a +4. Now we have this term, this expression here, and we know that we can combine like terms, right? We have a -2x and a -2x. If we combine those two like terms, okay, y equals x squared minus 4x plus 4. And this is our standard form. This is our standard form version of this vertex form. Right? We took the vertex form, x minus 2 squared, turned it into the standard form, written like this. So that's the simplest version of the scale. If we move on to like the next level, right, where we have to do one more step, that's if a is something other than 1. Right, so let's let h still be 2. Right, let's let h equal, oh, I changed the size of it. That's not what I meant to do. Yep, so h still equals 2. But let's say now a does not equal 1. Let's say instead that a was equal to, let's go with 3. So if a is equal to 3, when we plug in our three values here, we're going to get y is equal to 3 times x minus, or h value is 2, and we're going to leave k as 0 for now. In the next step, we'll talk about when k is not 0. But here, k is still 0, and, nope, I also forgot my squared. But when k is 0, we know that anything plus 0 is just itself, right? If you add 0 to something, you don't change its value. So this equation, we can just take this first part, copy and paste it, leaving out the 0 at the end. And this is our vertex form. And we can go about converting it in a very similar way that we did over here, right? We're still going to need to double distribute. The only difference is we now have this 3 out in front. And so a lot of people are going to start by distributing the 3 into this parentheses. That will be wrong, right? You don't want to do that. You do not want to take the 3 here and multiply by the x, because you have this exponent. And if you remember, I don't know if you guys have done order of operations before, where you have PEMDAS. You want to do parentheses first. That probably isn't spelled right, but that's okay. And then exponents before multiplication. So before we multiply anything by 3, we want to do this exponent. So we want to do this process of double distributing. And then after we've double distributed to solve for this squared term, then we can multiply by the 3. So I'm going to go through the process of double distributing again, because it may be new to some of you. Feel free to skip ahead in the video if you're comfortable with this already. But I'm going to put a bracket there, and think of a bracket as just like a bigger parenthesis. So we're just grouping everything inside of this bracket together so we know that it all stays together. I'm only doing that because we're going to need the parentheses for our double distributing. So we know that x minus 2 squared can be rewritten as x minus 2 times x minus 2. Okay, same step we took over here. And now we're going to repeat this first step of taking the first term, multiplying it by the entire second expression, then taking the second term and multiplying it again by that entire second expression. So that would look like we want to keep our y equals the 3 on the outside. And solving for everything in the brackets, we're going to take x times x minus 2 minus 2 times x minus 2. Okay, and so here I'm going to highlight this again. This is going to help us out a lot when we start factoring things in a couple of weeks. But this whole term went here and here, right? We distributed the x to that term, which gave us what we see here. We distributed the -2 to this term, which gives us what we see here. Right? We distributed each term in the first expression to the entire second expression. Now that we've done our first distribution, we can do our second distribution. And there I'm still going to have 3 with parentheses on the outside. And now I'm going to do x times x is x squared. X times -2, that's a -2x. -2 times x is another -2x. -2 times -2 is a +4. And we can close our bracket. Just as we did back here, we can combine like terms in the bracket. We get y is equal to 3 bracket. Instead, if you don't like the brackets, you can use parentheses and just have 2 sets of parentheses. That is also correct. I just prefer the brackets because I think they make it more clear that the parentheses are inside the bracket, so I know that the brackets are covering a bigger expression, right? They're further out. So we combine like terms, you see -2x minus 2x is -4x, and we can add the 4. So now that we've done the double distributing to deal with the exponent, right, to deal with the x squared, now we're going to deal with our a. Right now that we've done all this, we can distribute our a, we can multiply our a by this entire inner part, which we know is equal to this. So to do that, do y is equal to 3 times x squared, 3x squared, 3 minus 4x is minus 12x, and then 3 times +4 is +12. And so this here is our standard form. And if you notice, it takes the same form as this equation over here, ax squared plus bx plus c. We have 3x squared minus 12x plus 12. We did that by first double distributing out this x minus 2 squared and then multiplying by 3. So we have one more case here, and that's where k is also not equal to 0. So let's kind of, just to move things along, keep the same values, right? H is equal to 2, and let's say a is still equal to a still equal to 3. But now let's say that k is equal to, let's go with -5. Right? K is now -5. So what does that do to our equation? Well, when we plug in each of these values, right, a equal to 3, we write that out front. X minus h is equal to 2. So we put a 2 in there. And now k is -5. So we have a -5 at the end. I'm going to do that in the right color just because an effort into the color coding, and I might as well continue. -5. Okay. Well, we know how to do, basically, based on what we did in the last problem, we know what the first two steps is going to be, right? First, we're going to double distribute to deal with the x minus 2 squared, right? Exponents first. Then we're going to multiply by 3, right? We're going to do the multiplication there, times whatever we got on the inside. Well, now we get to go down further, right? We're probably not going to have division, but then we have addition and subtraction, which is last in our order of operations. So after we double distribute to expand this, we multiply by -3. Then at the end, that's when we subtract 5, because k is -5. Go through the same steps we did for the last problem. Again, for time, well, this time for time's sake, I'm not going to color code it. We can do 3 times parenthesis, x minus 2 times x minus 2. Bracket around it, we still have a -5 on the outside. We're going to keep the 3. We're going to multiply the x by this whole second term, x minus 2, minus 2 times this whole second term, x minus 2. Now we still have that -5 at the end. So after we've done our first distributing, and actually here I'm going to pause again because this is really important. This term went here and here. We multiplied our x by this whole second term. We multiplied the -2 by the whole second term. That was our first distribution. Now we can go ahead and do the second distribution. That would be x times x squared minus 2x, right? X times x times -2. Same thing over here. -2 times x is -2x. -2 times -2 is +4. All of that still in our brackets with our -5 at the end. I like the colors just for the -5. We're gonna make that green. Um, Now that we've done our exponent, right? We've dealt with the squared. Now we're gonna do our multiplication. If y equals, okay, actually, first we're gonna combine like terms. You can do it in either way. We'll combine like terms first and turn this into x squared minus 4x plus 4, right? Just combining the two -2x's. And then we still have -5. And we are going to distribute the 3, right? Multiply the whole thing by 3. So we would have 3x squared minus 12x plus 12. We know we didn't make a mistake over here. And finally, we have our last component, which is plus k, and k is -5. So here we have a plus and of -5, which as we can see is the same as just doing -5. So 12 minus 5 would give us 7. So our standard form would be 3x squared minus 12x plus 7. And this is the standard form, when the vertex form looks like this. So just to review, we have three cases. The simplest one where a is equal to 1 and k is equal to 0, and all you have to do is double distribute, right? We just take the first term times the whole second expression, the second term times the whole second expression, and then we do our second distribution and combine like terms. If our a is not 1, then after we do that double distribution, we multiply by a. And finally, if k is not 0, then once we do both of those steps, then we add k. So hopefully this was helpful. Let me know if you guys have any more questions.